Welcome to Module 2 of the Hare-Hale Root Cause Theory Training Program, focusing on the Hare-Hale temporal scale. In this module, we will learn how to convert effect sizes into human timelines. Our learning objectives are to explain why standard effect sizes need temporal context, define the 5 foundational terms of the Hare-Hale framework, apply the 3-step Hare-Hale formula to calculate years to proficiency, and identify when the Hare-Hale proxy applies. Effect sizes are contextless, without a reference frame. Knowing d equals 0.30 does not tell policymakers how long it takes to close a gap. The Hare-Hale solution converts effect sizes into school years, making abstract data concrete and showing the time needed to close gaps under different scenarios. Cohen's d is the currency of research, measuring the standardized difference between two groups. Effect sizes are categorized as small at 0.2 sigma, medium at 0.5 sigma, and large at 0.8 sigma, and are used to compare interventions across studies. Cohen's d is calculated by dividing the difference in means between two groups by the pooled standard deviation. In plain language, it answers the question how many standard deviations apart are the two groups. Hare's hinge point is 0.40 sigma, representing 1 year of typical student growth, based on a synthesis of over 800 meta-analyses. Any effect size above 0.40 sigma is considered better than typical schooling. The problem with effect sizes without context is that they fail to answer practical questions. For example, if an intervention produces AD equals 0.30 sigma, how long would it take to close a gap? Policymakers and parents need answers in years, not just sigma units. The Hare-Hale solution takes effect size and current score as input, processes them through the Hare-Hale formula, and outputs a timeline measured in school years. This makes the abstract data concrete. We have 5 foundational terms in the Hare-Hale framework. These include 1 school year, 0.25 sigma, 1.0 sigma, NAEP proficiency, and the Hare-Hale threshold. 1 school year is defined as 180 instructional days. This is the universal unit of time in the framework and excludes weekends, holidays, and summer break. The 0.25 sigma term is the U.S. national growth norm per school year. It represents the average amount of student growth in 1 year and serves as the benchmark for adequate annual progress derived from longitudinal data. The 0.25 sigma norm is a conservative floor based on research by Bloom, Hill, Black, and Lipsey. This conservative estimate is used because annual growth effect sizes tend to decrease across grade levels. The term 1.0 sigma is equivalent to 720 school days, calculated as 4 school years multiplied by 180 days. This is the key conversion factor between sigma units and instructional time. NAEP proficiency is a scale score of 238, which is the target for all Hare-Hale calculations. This score represents solid academic performance, as defined by the National Center for Education Statistics. The Hare-Hale threshold is 0.025 sigma, known as the critical floor. This minimum growth rate is 1/10 of the U.S. national growth norm. Below this threshold, timelines become generationally impossible, and the Hare-Hale proxy is applied. The 0.025 sigma threshold is 1/10 of 1 year's growth per NAEP cycle. Only severe stagnation or retreat produces growth this low, and it represents the mathematical boundary between difficult and impossible progress. The 3-step Hare-Hale formula is used to calculate the years needed to reach proficiency. Step 1 determines the gap to proficiency. Step 2 converts this gap into school years. And Step 3 is the Hare-Hale proxy, applied when growth is negative or subthreshold. Step 1 calculates the gap to proficiency, or G2P, in Cohen's d units. The formula is 238 minus the current score, divided by the standard deviation. This result expresses the achievement gap in the same metric used for effect sizes. In this worked example for APS all students, the gap to proficiency is 27.84 sigma. This calculation shows the distance from the NAEP Grade 4 Reading Proficiency Cut score of 238. A G2P of 27.84 sigma means the gap is nearly 28 times the annual normative growth rate. Even at perfect normative growth of 0.25 sigma per year, closing this gap would take over a century. G2P provides 2 key insights. First, it uses Cohen's d, allowing direct comparison of gap size to growth rate. Second, G2P measures only the distance to the target, independent of the growth rate. Step 2 converts the G2P measure into school years. The formula is G2P times 720 divided by 180. The 720 represents the school days in 1 sigma, and dividing by 180 converts the result back to school years. Continuing the worked example, applying step 2 to the G2P of 27.84 results in 112 school years. This is the amount of time required to close the gap at the national normative growth rate. The normative timeline of 112 school years at the 0.25 sigma norm is a severe indictment. It indicates that, at the U.S. national growth norm, proficiency is over a century away. The timeline of 112 years means a child born today in Albuquerque, growing at the national norm, would not reach proficiency until the year 2138. Critically, this is the best-case scenario at normative growth, as the actual growth rate is negative. Step 3, the Hare-Hale proxy, applies if the effect size is negative or below the 0.025 sigma threshold. If triggered, the proxy calculates the timeline as the 0.25 sigma school years multiplied by 10. The decision point for the proxy is whether the effect size is greater than or equal to 0.025 sigma. If yes, only steps 1 and 2 are used. If no, the timeline is multiplied by 10 using the step 3 proxy. In the APS example, the effect size is a negative 0.71 sigma, which triggers the proxy. Applying step 3 means multiplying the 112 years from step 2 by 10, resulting in a Hare-Hale proxy timeline of 1,120 years. The times 10 multiplier is a mathematical consequence of compound damage, not a penalty. A district at negative 0.71 sigma is increasing the gap every cycle. The 1,120-year timeline is the minimum penalty, as the true timeline is effectively infinite because the gap is growing. Positive growth is like compound interest on savings, where the gap shrinks and the timeline compresses. Negative growth is like compound interest on debt. Losses compound losses, and the gap grows, expanding by 0.71 sigma every 2 years in this example. The resulting 1,120-year timeline means that if Albuquerque maintains its current trajectory, grade 4 readers will not reach proficiency until the year 3146. This timeline is clearly generational and unacceptable. Let's review the full Hare-Hale formula at a glance. Step 1 calculates G2P, the gap in standard deviations. Step 2 converts G2P into years. Step 3 applies the proxy if the effect size is less than 0.025 sigma, revealing the compound damage factor. For our first practice problem, a district has a grade 4 reading score of 215 and an SD of 1.4. To calculate G2P, we use the formula 238 minus 215 divided by 1.4, which equals 16.43 sigma. For practice problem 2, using the G2P of 16.43 sigma, we calculate the years to proficiency at the national norm. The formula is 16.43 times 720 divided by 180, which results in 65.7 school years. In practice problem 3, the same district has an effect size of negative 0.15 sigma. Since this is below the 0.025 sigma threshold, the proxy applies. The Hare-Hale timeline is 65.7 years multiplied by 10, which equals 657 years. The Hare-Hale framework matters because it makes abstract data concrete by translating sigma units into years. It shifts focus to the growth rate and reveals the generational impact of policy inaction. The core insight of the Hare-Hale theory is that the timeline is determined by the growth rate, not the size of the initial gap. The growth rate is the most critical policy lever for change. This scene highlights the key terms we have reviewed, reinforcing the foundational knowledge needed to apply the Hare-Hale framework. In summary, G2P converts the proficiency gap into standard deviation units. The formula translates G2P into school years at normative growth. Finally, the proxy captures the compound damage of sub-threshold growth with a 10 times multiplier. To wrap up Module 2, consider these review questions. What are the 3 steps of the formula? When does the proxy apply? And what is the significance of the 0.025 sigma threshold?